Okay, good morning. So let us continue the lesson. This is the title is Newton's Binomial Theorem. To motivate why what we are going to do is we start with Math 1C problems, if you remember. So if I have a plus b, two real numbers, if I ask you what happens if I raise it to power 1, to be honest, nothing strange will happen. It becomes the same thing. But then we also learn that what happens if I have this binomial means that I have a polynomial with two terms. So that's why it's called binomial. And when I square it, the answer becomes the first one squared 2 times the first one times the second one, and then plus the second one squared. Yes. And of course, these are famous for you, but in the formula sheet, you always get the formula for the third one as well. So the third one is a to the power of 3 plus 3a squared b plus 3ab squared and plus b cubed. Now that's the question. The question is that, is there any nice pattern going on so that we should be able to raise a plus b to any nth power? Yes. For example, what do you expect for having a to the power of a plus b to the power of 4? And then what do you expect for having a plus b to the power of n? So the answer to the last question mark is Newton's binomial theorem. So we want to see what will happen if, of course, n is a natural number, any natural number. Of course, one way to understand, this is not a technically hard problem. So for example, if I ask you to prove this, what you can do, you can write these 3 times and multiply them term by term to see how is it going. And for the same thing here. But of course, it becomes computationally costly when n becomes larger and larger. Yes? So it would be a good idea if we can find a formula for the general case where n is an arbitrary natural number. And then, by the way, this is an algebra problem. It's not a combinatorial problem. But that is the reason that we discuss it in combinatorics, is because using the ideas we learned in combinatorics, we can prove the general formula in a slightly easier way, in a different way, which is of course easier than if I want to do it algebraically. Okay? So how we do that? Let us look at the patterns, yes? So for example, for the case of a plus b to the power of 3, I hope that you can guess what will be the pattern of the terms involved in the answer. So you have a plus b times a plus b times a plus b. And then let us look here. So the terms involved without the coefficients, I have a cubic term, I have a squared b, I have ab squared, and I have b cubed. Yes? And I think you can immediately guess yourself what will be the form of the terms involved if I have the fourth power. Yes, a plus b, a plus b, a plus b, a plus b. So can you guess what are possible terms that will be in the answer, regardless of the coefficients sitting in front of them? So what are the terms involved? So for example, how do you think because when you want to multiply 3 binomials, you need to choose one of these terms from each pairs of bracket, yes? So for example, if I choose a from the first one, a from the second one, and a from the third one, and multiply them, definitely I get a cubed, yes? But how do you think I get a squared b? A squared means that a has been chosen 2 times in these 3 and b has chosen once, yes? So this means that I choose 2, for example, from this one I choose a, from this one I choose a, but from this one I choose b. Yes, it gives rise to a squared b. Do you agree? But this is not the only way that I can construct a squared b. In how many ways I can construct a squared b? To construct a squared b, I need to choose 2 a's and 1 b. Okay? It is possible to choose these two A's and this one B. This is one option. But I can choose A from here and from the last and B from here. This is another option. And there is also only one more option, that I choose A's from the last two and B from the first one. Do you agree? There are no other ways that I can construct A squared B. So this means that A squared B definitely occurs in the expansion, but how many times it will occur? 3 times. So if I start expanding that, I will face A squared B 3 times in my expansion. But because A squared B can be added to A squared B can be added to A squared B, what I will get what? 3A squared B. Is that clear? So that is the argument that we want to follow in general. So for example, let me ask you, what is your opinion about the terms involved here? Can you guess what are the form of the terms without the coefficients for the time being? So you might say that, okay, I can choose A from here, A from here, A from here, A from here. It gives rise to which term? A to the fourth, yes? But, and then I might choose 3 A's but 1 B, yes? So either I choose all of them A's, or I choose 3 A's and 1 B. Do you understand what I mean? It means that I choose 3 of these pairs and choose A from those three pairs, and then choose B from the rest. It gives rise to A cubed B. And then what is next? What is the other possibility? I might choose 2 A's and 2 B's, yes? So if I choose 2 A's and 2 B's, then it gives rise to what? A squared B squared. I might choose 1 A but 3 B's. It gives me AB cubed. Or I might choose all of them B's, not A at all, so it becomes B to the fourth, yes? So this is not hard to understand, that these are the only possible terms involved, but we need to know the coefficients. For example, can you tell me what is the coefficient of this one? If I ask you what is the coefficient sitting, if I ask you what's the coefficient, it means that I need to think how many possibilities are there if I choose A's, 4 A's. When I say I want to choose 4 A's, it means that from this one I choose A, so it means that there is one option. I have to choose A from all of them. So the coefficient should be 1, yes? But if I ask you what is the coefficient of A cubed B, it means that I need to think about the possibilities, all possibilities that I choose 3 A's and 1 B. For example, I can choose A, 3 A's from these and 1 B here, but that's not the only option. You need to consider how many options you have. Okay, let us just count this manually first. So for example, let me write here. For example, you can say that I choose A from here, A from here, A from here, B from there. This is one possibility. Or I can say that I choose A from here, A from here, A from here, but B here. Or I can say what? I can choose A, B, A, A, or I can choose B, A, A, A. Do you agree with me? These are the only possibilities if I want to choose 3 A's, 1 B. There are no other options. But if I multiply them, it becomes A cubed B. If I multiply these, it becomes still A cubed B, A cubed B, A cubed B. How many of them you see? 4. So it means that in this expansion, 4A cubed B appears. But because all of them are similar, when I want to simplify them, I add them up. So what you get is 4. So this is the number that you get. Yes? Okay, let us check this one. Then, of course, we want to understand this process and then use combinatorial knowledge that we have gained so far to answer this question in general. Now, let us try to understand what is the coefficient of A squared B squared. So this means that this time I need to consider 2 A's and 2 B's, yes? So let us check. For example, one scenario is that I choose A here, B here. We need to be careful not to miss a point in an item. So this is one possibility, yes? It gives a rise to A squared, B squared. But how many options I have? For example, I don't know, you can also help me. So what do you think we should do? I start with an A, okay? And instead of having A here again, which gives rise to the same thing, I put B here, then I put A here, then I put B here. This is one possibility. Yes? Another possibility is that I have A again here, B here, B here, and A here. Yes? These are three options. I think these are the only three options if I decide to start with an A. I can do the same thing starting with a B, yes? If I start with B, it means that wherever I see A, I put B, yes? This is the cheating way of doing that, yes? And then here, B, A, B, A, and then I have B, A, A, B. So, I don't know, do you think there is other possibilities here? I want to have two A's in my list and two B's in my list. I think this is the only one. So how many items are there? 6. So we expect that if we expand them, 6 A squared, B squared will occur. And that's correct. And then, for example, if I ask you, can you guess what is this one? Because that's the same thing, but the roles of A and B are interchanged. So can you guess what will be this number without doing this? Yes? 4. It would be 4, because that's the same thing, but A is changed to B, B is changed to A. So that would be the expansion. Okay? Is that clear? Okay, now I think we are ready to tackle the general problem. Okay, so to tackle the general problem, so let me write it here. I have A and B real numbers, and I have N a natural number. And I want you to tell me how should I write A plus B to the nth. So I hope that you can guess what are the possible combinations that you expect. For example, one of the possibilities is what? So if you want, I can write it as A plus B, n times, yes? Okay, so let us consider the combinations that might happen in the expansion of this. So might be I decide to choose to choose A from all of them, so I will get A to the nth. Yes? So what is the next term that you expect? It's better to write them in an organized way. So what is the other one?
A power to n minus 1.
But 1b. So it means that I choose 1b. Here I haven't chosen any b's. I have chosen all a's. But it might happen that I choose 1b, the rest of them a's. 1b, the rest of them a's means I have a to the power of n minus 1 because I am multiplying a n minus 1 times and 1b. Yes, that's one other possibility. So another possibility is what? Can you tell me? I just want you to see the pattern. So what's the next term? Yes, I have chosen no b's. I have chosen 1b, and now I want to choose 2 b's. If I choose 2 b's, it means that the rest of them I should choose a's. Yes, for the rest of them. So it means how many a's are there? In total, there are n pairs of brackets. 2 of them I choose. I choose b in 2 of them. So a to the power of n minus 2 are left. And if you don't mind, let me make it a little bit bigger with more space so that I can fit the coefficient inside after we learn what to do. Okay? And what is the next one? I hope that you agree it is a to the power of n minus 3b cubed. Is that understandable? Yes? Now I choose 3b's, the rest of them a's, and I continue my list. So I continue my list. For example, I reach to the other way around. So it means that I choose b to the power of n minus 3, but 3 a's, and then I choose 2 a's, the rest of them b's. I choose 1a, the rest of them b's, and finally all of them b's. Is that understandable what I'm doing? So it means that in general I will expect all these terms. But the important thing are not the terms, because they are more or less obvious. I need to know the coefficients. So I think you agree with me the coefficient here is 1. Because if I want to generate a to the nth, I have one option. And I have to choose a from all pairs of brackets. So there is one option. Or if you like, you can say that I have a up to a. In how many ways I can arrange a's in a row? One way. There is no difference. But when it comes here, you can see it in two different ways, using permutations or using combination. For me, usually permutations are easier. What happens for this case? How many a's I have? I have n minus 1 a's, and I have only one b. If I ask you arrange them, in how many ways you can arrange them? In total, how many objects I have? N objects, so it becomes n factorial, but n minus 1 of them are being repeated. So I have, do you remember, I have to divide by n minus 1 factorial. And if you want to, because I want to I want to discover the pattern, I prefer to write it in that way. So do you agree? Of course, you can guess, it is just n, because n times n minus 1 factorial, n minus 1 factorial are gone. So what is left is n. But if you don't mind, I would prefer to write it exactly like this, because I want to see how the pattern is going. Okay, so what can I have for this coefficient here? In this case, I have a list of a's and b's. How many a's are there? N minus 2 a's. How many b's are there? 2 b's. So if I want to take my list away, my list is now n minus 2 a's but 2 b's. So if I ask you arrange them in a row, in how many ways you can arrange them? Again, the numerator is what? N factorial. But the denominator, now I have n minus 2 objects repeated of the same type and 2 objects of the other type. So this becomes, hopefully you agree, it is 2 factorial, n minus 2 factorial. Yes? Okay, can you tell me what is the coefficient of the next one? Just by seeing the pattern, yes? I think the pattern is obvious. This time you have again n objects, but 3 of them are b's, and n minus 3 of them are a's. So what should I write for the coefficient of the next one? Yes?
N factorial over 3 factorial n minus 3.
Yeah, exactly. But I want you to understand, not just looking at the pattern. Do you understand why this number is the correct number? Because now I have n objects, but 3 of them are of the one type, and n minus 3 of them are of the other type. We have already learned what to do with repetition, yes, coefficient with repetition. I think the pattern is now very clear. So can you tell me, for example, what will happen at the very end? Now you can see the pattern, what's happening. It is clear that n factorial is repeating itself. By the way, if you insist, what can you write for the first one if you want to follow the pattern? You can write n factorial, 0 factorial, n minus 0 factorial if you want to. Yes? Because 0 factorial is just 1, n minus 0 is n factorial divided by n factorial, so this is 1. That's a fancy way of writing 1, but the benefit is that you can see that it's also following the same pattern, yes? So n factorial is repeating itself all the time, so it will repeat itself again here. But see, 0 is representing the number of b's. Here we do not have any b's. And then here you see 1 is the number of b's, 2 is the number of b's, 3 is the number of b's. So what should I write here now? I need to write the number of b's, which is n minus 3 factorial, yes, times n minus this number, which is 3. Yes, do you agree? Let us just do it in our head. It becomes 3 factorial. And the next one becomes n factorial, n minus 2 factorial, 2 factorial. Do you see why this is 3 factorial and why this is 2 factorial? Because I always have n minus the number of b's. In this case, n minus the number of b's becomes 3. Yes. Okay. And then the same story here. So n factorial here, n minus 1 factorial, and then 1 factorial. And if you want to, you can write n factorial, and 0 factorial. Okay, and usually if you have a big sum, it is better to use the sigma notation to write it in a more compact way. Yes, so what can I write as a sigma? Can you help me? So this becomes a sigma. A sigma needs a counter, so if you don't mind, let me call the counter k. And then the terms are a to the power of n, a to the power of n minus 1, a to the power of n minus 2, etc., etc. So I hope that you agree that I can write it as a to the power of n minus k, but multiplied by b to the power of k. Yes, do you see that all of them have this pattern? So here an is actually anb0, which we didn't write. And then this is an minus 1 b to the power of 1. This is an minus 2 b to the power of 2. And then a to the power of n minus 3 b to the power of 3, and etc. So hopefully, I hope that you agree with me that these are the good, this is the one way to write this sum. But k starts from where to where? You see that the power of b is 0, and then it becomes 1, then it becomes 2, and it goes up to n. So the counter, which is the power of k, it goes from 0 up at most n. Yes? And now let me write the coefficients here. For the coefficients, the numerator of all of them is n factorial. Okay, can you help me to write the denominator now, using what you see? You need to tell me something so that when I put 0 in the denominator, it gives me the first denominator. If I put 1 for k, it gives me the denominator for the second. If I put 2, it gives me the denominator of the third one. It is clear. What should I write in the denominator? I need 2 factorials, yes? So what is this one? Yes? Are you seeing what's going on? Or this 1 hour changing time has affected you? Are you still sleeping or not?
Isn't it just k?
Yeah, the first one is k factorial. But what is the second one?
N minus k.
N minus k factorial. So that's the general formula. And that's what is called Newton's needle. But there is another symbol we use for this. Do you remember? This is the n choose k. So this becomes sigma n choose k. And then you have a to the power of n minus k, b to the power of k. K goes from 0 to n. So this is final form of Newton's binomial theorem. So if I have a plus b to the power of n, I can write a sigma, remember, k the counter, whatever you call it, k, j, or whatever. It starts from 0, not 1, and it goes up to n, which is this n. And then you have a combinatorial number. What sits on top is exactly the power, and what sits at the bottom is actually the counter. And then you start with a. What is a? A is the first term in your binomial. To the power of n, n is your power, minus the counter k, and b to the power of counter. What is b? B is the second term. So that is the famous binomial theorem. Newton's binomial theorem. Yes? So for example, let us use this to expand a plus b to power 5. If I ask you to calculate this, to expand that, so you just write the formula. So the formula is k goes from 0 up to where? N in this case is 5. And then you have a combinatorial number. What is sitting on top is exactly the power, and what is sitting on the bottom is actually the counter. And then you take the first one to the power of 5, because n is 5 in this problem, minus k, and then b to the power of k. And of course, this is the formula, but you have to expand that. So expanding this means I need to open up the sigma. How should I open up the sigma? I replace my counter with the values from 0 up to 5, one at a time. So I choose 0, so it becomes 5, choose 0, a to the power of 5 minus 0. Let me write everything in detail that you understand what is going on. And the next one, I just follow. I don't need to look at the formula anymore. I start adding the numbers to the counter. So 5, 1, a to the power of 5 minus 1, b to the power of 1. And the next one is 5, 2, a to the power of 5 minus 2, b to the power of 2. And then I have 5, choose 3, a to the power of 5 minus 3, b to the power of 3. You can do a lot of calculations in your head. I am just intentionally writing it for the first time. So a to the power of 5 minus 4, b to the power of 4. And finally, I have 5, 5, a to the power of 5 minus 5, b to the power of 5. Yeah, is that clear? So I'm just expanding that sigma. I told you, you really don't need to write it so much. So you write so much, you can do these calculations in your head. But let me just do it. So do you remember what is 5 choose 0? 5 choose 0 is one of those exceptional ones that you cannot usually understand it from combinatorial perspective. You need to calculate it, but it's good to know this always 1. So if I have n choose 0, the answer is always 1. Why? 5 factorial, 0 factorial, the difference between them is 5 factorial. And then you see that the answer becomes 1. So the answer to the first one is just 1. I don't need to write it. b to power 0 is also 1. a to power 5 minus 0 is just simply a to power 5. Yes? And then we go to the next one. What is the number here? You can just calculate it with the combinatorial argument. You have 5 students. You want to choose one of them. In how many ways you can do that? 5 ways, if you like it in that way. If you don't like it in that way, you can use the formula and calculate it. In any way that you do it, it becomes 5. And then I have a to the power of 4, b to the power of 1, which I simply write b. But for the next one, we have to calculate 5, 2. What is 5, 2? It's 5 factorial, 2 factorial, 3 factorial. And if you calculate this, it becomes 10. So this becomes 10. But can you, without calculation, I don't know if you remember, what is 5 choose 3? It's the same as 5, 2, yes? Because this either you calculate it or you think in that way. The number of ways that I can choose 2 students to take with me is the same as if I choose 3 students not to take with me. So the numbers should be the same, yes? So that's also 10. So let me write this 10, a to the power of 3, b to the power of 2, and the next one is also 10. Even though they are different, the answers are the same. It becomes a to the power of 2, b to the power of 3. Okay, can you tell me what is 5 choose 4? It's 5, because 5 choose 4 is the same as 5 choose 1. Yes? So this becomes 5 again. And finally, the last one, 5, 5. I have 5 people, I want to choose them all. There's only one way to choose them all, yes? So this becomes a to the power of 0, which becomes 1. Let me not write it here. And then it becomes b to the power of 5. So that's the expansion of a plus b to the power of 5. Is that clear? But of course, I can teach you a little bit faster way. You can use it if you want to. So if I want to do that, of course, this is also can be proven using combinatorial arguments. Well, I mean, using algebraic arguments about these combinatorial numbers. So if I want to choose that one, what I do, I know about the term, so I know that the first term should be this one, the next one will be this one if I want to write them order. Of course, you know that in addition, order doesn't matter, but let us respect the order. And then I will have a to the power of 2b3, then I have ab4, then I have b to the power of 5. So the first one I know it's 1, yes? The second one, if I want to calculate, I do it in that way. I multiply 5 here. I multiply the power of 5 to the coefficient, which is 5. And then how many terms I have written so far? 1 term, yes? 1 term. So it becomes 5 times 1 divided by 1. The answer is 5. So the number here is 5. Okay, let me repeat again. If I want to find the next one, what I do, I take the power of a, multiply it by 5. And how many terms I have written so far? 2. So I divide by 2. So the answer becomes 10. Yes? And for example, for the next one, I take the power of a, multiply it by the coefficient, which is 30. How many terms I have written so far? 3. So I divide by 3. And it becomes 10 again. So this becomes 10. And then the rest of it, by the way, I really don't need to calculate anything after that because they are repeating themselves. Yes? So if I calculate up to here, then I don't need to calculate the rest of it because the terms equidistant from the center, they have to have the same coefficient. So if this is 1, this is 5, this is 10, then again from the end, it should be 1, this should be 5, this should be 10. So you really don't need to calculate. If you calculate half of them, roughly speaking, then you have all of them. Yes? For example, if I want to ask you, for example, calculate this to the power of 7, so you can write a7, a6b, a5b2, I don't know, a4b3, a3b4, and then I have a2b5, and then I have ab6, and finally b7. Yes? So let us try to write that. You know that the first coefficient is 1. Then what is the second coefficient? Is 7 times 1 divided by 1 because so far I have written. So this is just simply 7. Okay, can you tell me what's the next one? What is the next one? You take the power of a, which is 6, multiplied by the coefficient, it becomes 42. But how many terms you have written so far? 2, you divide by 2, it becomes 21. So this number is 21. So what about the next number? I multiply 5 by 21. How many terms I have written so far? 5 times 21. How many terms? I have written 3. 3 and this is 7. 5 times 7 is 35. So the next number is 35. But do I need to calculate the rest? You can calculate with the same method. But because I have calculated half of the coefficients, I have to repeat them symmetrically, yes? So if this is 1, the last one is 1. If this is 7, the 1 to the end is also 7. And then if this is 21, this is also 21. And if it's 35, this also has to be 35. So that's the expansion of that. Of course, it doesn't matter. If you want to do it faster, this is better. Otherwise, that is the general formula. Is that clear? Okay, but this is not the only type of questions that you get. One thing that I want to mention is that it is a matter of confusion sometimes. You see that if I ask you, what is the number of the term here? This is the first term. But the first term corresponds to k equals to 0, not 1. You remember? So when I expand this sigma, this is not the 0th term. This is the first term. But when I get the first term, when I put k equals to 0. So when I put k equals to 0, I get the first term. When I put k equals to 1, I am not getting the first term. I am getting the second term, yes? So because that's clear, when I write these numbers in a list, yes, if 0 is not there, the order is very natural. The positions are natural. So this number 1 is the first location, number 2 is the second location, number 3 is the third location. But when I start from 0, the first location is not occupied with 1, it's occupied with 0. So k equals to 0 gives me the first term. K equals to 1 gives me the second term, and etc. So that's something that you need to remember. So let me write this here. So if I ask you, let us, I is somewhere between 0 and n, I belongs to z, okay? If I ask you what is the ith term, what is the ith term here? Of course, by the way, when I say the ith term, I mean in this organized sum, because you can rearrange them. Addition doesn't change, you know, but if you write it in organized way, in order, then if you go from left to right, what is the ith term? If I want to get the first term, I need to put k0. If I want to get the second term, I need to put the counter 1. If I want to get the third term, I need to put the counter 2. So if I want to get the ith term, what should I put the counter? If I want to find the first term, the counter should be 0. If I want to find the second term, the counter should be 1 unit less. If I want to have the third term, the counter should be 2. So if I want to have the ith term, the counter should be I minus 1. So it means that if you want to find the ith term, you have to put I minus 1 for the counter. So this becomes n I minus 1, a to the power of n minus I minus 1. The minus sign goes in, and then b to the power of I minus 1. Yes? So this is something to remember. So this is, let me emphasize here what I mean. So this is ith term, but here remember, this is I minus 1. This is also I minus 1. This is also important to remember. So that's my point. It's not hard to understand, but sometimes you get confused. You think that, okay, when I put k equals to 1, I get the first one. This is not the case. Okay, now let us see what else we can do. So there are two types of questions. One question is expansion. We learned a little bit about this standard one, but let me give you another example. Okay, so for example, let us expand the following. For example, 2x minus 3y to the power of 4. Okay, so let me use the standard one which is in your book. So I want to use the formula which is in that curly curve thing there. But here, I need to give the role of a to what? To 2x. I need to give the role of b to minus, it's important, minus 3y, and I need to give the role of n to 4. And I place them in that formula. So this becomes equal to sigma. K is just a counter. You can choose whatever letter you want to, except the ones that are used here. K goes from 0 up to n, but n is 4. Then I have 4 choose k. Then I have a, which is 2x to the power of n minus k. And then I have minus 3y to the power of k. So the first thing you do is just to write this, and then you have to write the expansion form. And then you have to calculate all the coefficients, unless the coefficients are so big that I ask you not to do that. Okay, so this becomes what? I put 0. And this becomes 1. Let me not write the extra things we don't need. And then I go to the next one. Yes, I replace k with 1. 4 minus 1 is 3. This is just 1. And I go to the next one. And I go to the next. And finally, yes. So this is the lesson, but the rest of it is just the old lesson. You have to calculate these things. So hopefully you'll be, this is 1, but 2x to power 4 is 16x to the 4th. Okay, let us do the calculations here in our head. So what is the number here? This number is 4. There is a 2 to power 3, which is 8 coming in, and there is a minus 3. You have to multiply all of them. Yes? So what's the answer? Is 96, but I have a negative number, so it's minus 96. But x to the 3rd, just y alone. Yes? Okay. And if you calculate this, it's not hard, so you write 4 factorial, 2 factorial, the difference between them, again 2 factorial, this becomes 6. And then, so this is 6. And then 2 power 2 is a 4, minus 3 to power 2 is a 9. So 216, positive, so it is 216, x to the power of 2, y to the power of 2. But 4, 3, hopefully you know that is just 4 again. This is a 2, and that's minus 27. Yes? So if you multiply them, it's also coincidentally 216, is that right? Yeah. So don't get confused. The symmetry is broken here. So don't think that the coefficients should be the same, because that is for the original one that I have a and b. Here you see that I have different coefficients here. So this will affect the coefficients. So, but that was a coincidence. So if I did my calculation right, it's also minus 216. There's a minus sign here. And then I have y cubed. And here this is plus 81 y to the power of 4. And I emphasize again, don't get confused. You see, these coefficients are not equal. These coefficients are not equal, and that is already expected, because what I told you are these coefficients, these combinatorial coefficients are the same from these distances. But now they are being affected by being multiplied by some other coefficients. So this is the expansion of that. Is that clear? Okay. But this is not usually the main type of questions that you face. So for example, let us actually give more examples. I start with a little bit simple one. So example, what is the coefficient? What is the coefficient of x to the power of 5, y to the power of 13 in the expansion of 3x minus 2y to the power of 18. Could I ask you what is the coefficient of this in this to power 19? Can I? Yes or no? The answer is no. Unfortunately, I raised that. But you know that the pattern of these powers, yes, they have to add to the power that you are working with. It's not possible to have an x. You see that this is 5. What is this one? Oh, so this is 1. 4 plus 1 is 5. 3 plus 2 is 5. 2 plus 3 is 5. 1 plus 4 is 5, and that's also 5. So the sum of the exponents should be the power that you have. So it is not possible to give you this and then give you the expansion like that, because the sum of them is 18. So you should expect, when I wrote this, you should be able to give me the exponent yourself. So this should be 18. Okay, so you want to answer this question. If you want to answer this question, I want you to learn not to expand the whole thing and see where this appears. So what you need to write, I would write it like this. So let me write the formula in front of your eyes, which you have it in the formula sheet, of course. K goes from 0 to n, and then you have n choose k, a to power n minus k, b to the power of k. So that's my original formula. But I want to answer something related to this, so you realize that a has to be replaced with 3x, b has to be replaced with minus 2y, and n has to be replaced with 18 in my formula. So then what happens? This becomes 3x minus 2y to the power of 18 is equal to the sigma k goes from 0 to 18. And then I have 18 choose k. What is a? A is 3x. To the power of n, which is 18 minus k. B, which is minus 2y to the power of k. Yes? And what I expect you to do is to formally write them. What do I mean? So I would write 18 choose k. K goes from, of course, 0 to 18. And then I have 3 to this power coming out. Yes? And then I have minus 2 to this power coming out. And what is left for me is x to this power, y to this power. Unfortunately, these are stains on the whiteboard, so they are not dots, but this is it. So what I did, I have my formula in front of me. I did the appropriate replacements. I got this, but I see that there are some coefficients also here involved here. So I separated them. So this is my coefficient now in total. But of course, according to the problem, I am not interested in all the terms. I am interested in this term. So this means that I have to choose k appropriately. So this gives you this term. Which choice for k will give me this term? 13, yes? If I choose k to be 13, this becomes exactly what I want. So this means that the question mark, which is the coefficient, this is the coefficient for all the terms, but because I want to get the coefficient for this one, I need to choose k to be 13. So this becomes 18, choose 13, and then 3 to the power of 5, multiplied by minus 2 to the power of 13. Is that right? So, and I don't ask you to calculate this. If you write it like this, that's acceptable. Of course, if you want, you put it in the calculator and find the final answer. But that is not needed here. So one common mistake is that usually people say immediately this is the coefficient. This is the coefficient if there are no coefficients here. But if there are some coefficients here, you should also take them into consideration in this way. Yes? Okay, so let me give you one more example. In the expansion of this expression, this is the last example for today. There is one small part of this chapter that is called pigeonhole principle that I skipped. If I teach that one, then this is also finished. So consider this expansion, the fourth root of x cubed plus 1 over the third root of x squared to the power of 17. Okay? So the question is that, is there any term independent of x? Is there any term independent of x in this expansion? If so, what is it? So let me tell you what do I mean by independent. For example, in Math 1C, I could ask you, give me the term independent of, let me write it with the same letter x. So, is there any independent term? Is there any term independent of x in this expansion? And if yes, what is that? So you know it from Math 1C, if you want to raise it to power 2, you would say the first one squared, and then you would say 2 times the first one times the second one, and then second one squared, which is a particular case of this lesson today. And then you see that these are designed in a way that when I do that, what happens, I get a term which is independent of x. It means that there is a term in which x does not appear. That is the meaning of being independent. And if I ask you, is there any independent term here? You would say yes. And if I ask you what that term is, the answer is 2. Yes? I am asking you the same question, but of course for this more complicated problem. Is that clear what I mean by independent? Okay. So how should I answer this question? This is a binomial because I have the sum of 2 terms. I want to raise it to power 17. So you need to think, okay, that's a problem in binomial theorem. So what should I do? So let me write the formula here again. I don't know why I'm erasing this formula all over again. So this is n choose k, a to power n minus k, b to power k. K goes from 0 to. And then, of course, I replace a with the fourth root of x cubed. But this is also can be written as the form of 3/4, x to the power of 3/4. And then I replace b with that expression 1 over the third root of x squared, which is x to the power of minus 2/3. Yes? This becomes 2/3. I bring it up, it becomes minus 2/3. And then if I ask you what is n, n is 17. Yes? So I put these replacements in the formula, so the question mark, the expansion becomes equal to, that's not the question mark, so that expression to power 17 becomes equal to sigma, k goes from 0 to 17, and I have 17 choose k, and then I have this number, x to the power of 3/4 to the power of n minus k. N is 17, k is just k. And then b, which is x to the power of minus 2/3 to the power of k. This is what I have. But let me simplify this a little bit. So this becomes sigma, k goes from 0 to 17, 17 choose k. But here, let me multiply 3/4 here. So this becomes x to the power of 3 times 17 minus k over 4 multiplied by x to the power of minus 2k over 3. Yes? So let me use this as the dot here. Yes? But of course I can go a little bit further because I have two exponents being multiplied, but the bases are the same, so I can write the same base and I can add the exponents. So this becomes what? Sigma k goes from 0 to 17, 17k, and then it becomes x to the power of 3, 17 minus k over 4 minus 2k over 3. So yeah, let me make this a little bit bigger. So this is x, and the whole thing here you see is the exponent of x. So this is the general way of expanding this a little bit complicated expression. But how can I answer the question? I want to answer this question. Is there any term in this expansion which is independent of x? When do you think independence of x occurs? Yes?
When the exponent is equal.
0. If it happens that one exponent is 0, it means that there is no x involved in that particular term. But this is not clear. I have to ask myself, is it possible to have this one 0? Okay, let me ask you some questions before going forward. So let us say that I solve this equation, I get k equals to 2/5. Assume that. So what do you say the question is? What is the answer to the main problem then? Assume that you solve this and you get this number. What do you say?
70 choose k.
No, if I get k is 2 over 5.
Because then x is 1 and it's asking for the term.
No, assume that I get k to be 2 over 5.
There are no independent.
There is no independent term because k is the counter. Counter cannot be a fraction. Counter is either 0 or 1 up to 17, yes? So, for example, you get k to be 19. What do you answer?
There are no.
There are no, because at most the counter, the maximum value is 17. So in some cases, might be they have designed the question, I don't know, so that you get a fraction k, or you get something greater than the highest value for the counter. You shouldn't be in a hurry and say that, okay, I have a term. You should say that, no, there are no terms independent of x, because this cannot happen, yes? Okay, but let us see how this will go. If I want to do that, I multiply everything by 12 to get rid of the denominators. So this becomes 3 times, it becomes 9. 17 minus k, and then it becomes minus 8k equals to 0. Yes? Okay, and then I multiply it, so 9 times 17 minus 9k minus, that is minus 17k. I intentionally didn't multiply because I knew that I am going to divide. Yes? So this, I move it to the other side and then divide. So what k is? K is 9. But 9 is acceptable because it is an integer and it is in the appropriate range. So k is 9. But the answer to this, is there any term independent of x in this expansion? The answer is yes, because I was able to find an appropriate value for k. But they have asked you, if so, what is it? What does it mean? It means that you go back here, you replace k with 9. But you don't need to recalculate this. It is clear that if I put k9 here, it becomes 0, x to the power 0 is 1. So what I need to calculate is only 17 choose 9. Yes? So the answer to this problem is yes. What is it? It is the number 17 choose 9. Is that clear? Okay, if I want to write them in order, which term is it independent? So for example, in the case that I gave you this example, the middle term, the second term from the left was the independent term. So which term is independent here? if I start writing them in order. Of course, which term doesn't make that much sense because you can just replace them, yes?
Is it the 10?
It is the 10th, yes? Because I told you that when you, k starts from 0, so 0 is the first term, yes? 1, k1 is the second term, so when k is 9, it is the 10th term. So if I want to write them in order, the 10th term and only the 10th term is actually independent of x. Is that clear? Any questions? Okay, I think we stop here now.